All right, in this video, we're going to be talking about section 5.3, which is going to look at more rules for multiplying with exponents. So to begin, let's take a look at a couple of quick questions here. So the first is 3 to the 6th squared. So I want you to think about what 3 to the 6th squared is really telling us to do. And it's saying take whatever this is, in this case 3 to the 6th, and multiply it by itself 2 times. So I've written 3 to the 6th times 3 to the 6th. And we know that that means we are going to use our rule about multiplying numbers with the same base. And this is simply going to be 3 to the 6th plus 6th power, or 3 to the 12th. 2 squared to the 5th power means we've got 5 of these 2 squareds being multiplied. So we've got 1, 2, 3, 4, 5 of them. And I know that using my multiplication rules that I add their exponents. So I have 2 plus 2 is 4, 6, 8, 10. So that's just going to be 2 to the 10th. And then this last one here, g to the 4th cubed, is simply g to the 4th times g to the 4th times g to the 4th, which we know equals g to the 4 plus 4 plus 4, which is 12th power. All right, so didn't use a new rule, just use the old rule. But let's look at the result of what happened. We had 3 to the 6th, and we had that 2 times. So we had 2 groups of 6, which is why 6 plus 6 is 12. But another way of doing 2 groups of 6 is simply multiplying 2 times 6. So what I want you to notice is this problem simply says you have a power raised to another power. So 3 to the 6th raised to the power of 2. And the result was just the same as doing 2 times 6, 12. Here we got 2 to the 10th, which is just doing 2 times 5. And again, why are we getting 2 times 5? Because this is saying we have 5 groups of these 2 2s. So when you have 5 groups of something, that's what multiplication does. So g to the 4th cubed, we multiply the powers together, and we get g to the 12th. So that is the faster way of getting to the same answer we got the first time. And that brings us to our first rule of the day, raising a power to a power. So for every non-zero number a and integers m and n, if you have this situation, a to the m and then that raised to the n power, then all you do is multiply the 2 powers together. So let's apply that rule. Example 1, the rule says power to a power we multiply, so this should just be 5 to the 8th power. N to the 2nd to the 5th, that just becomes n to the 2 times 5th power. A to the negative 4 times 3 would be a to the negative 12th, but we're going to use our other rule and simplify this problem to be 1 over a to the 12th. So that's where things get complicated. Not any individual rule. Every individual rule is very simple. It's when we have to do 2 or 3 or 4 rules within one problem that we can get a little bit lost. So let's take a look at the next one with that in mind. So based on today's rule, we know that we have an exponent raised to another exponent. And we know that that's going to have to take priority because exponents, so this negative 2 exponent on the outside, takes precedence. So the first thing we're going to get is we're going to get c to the 5th times c to the negative 6th. Then we're going to use the rule from before. We know we're multiplying by the same base. We add the exponents. 5 and negative 6 make negative 1. But yet we're going to use then our first rule we learned and know that a negative exponent means move it. So the best answer here would be 1 over c. Lots of little rules, but if you attack one at a time, pretty simple. Power to a power, we multiply these. So you have a to the 8th times a to the 10th. Now we have our rule that says, oh, you've got 8 a's and then 10 more a's. So we have a total of 8 plus 10 or 18 a's. All right, let's explore further. How can you use repeated multiplication to evaluate 2y, the quantity cubed. So in this situation, we've got both the 2 and the y are being raised to the third power. So let's just write what that literally means. 2y times 2y times 2y. And we know we can multiply in any order. We know there's no special arrangement between the 2 and the y. It's just multiplication. So this problem really just says 2 times y times 2 times y times 2 times y. And I write this just to further illustrate that it's not a 2y necessarily. It's a 2 and it's a y. And long story short, we can multiply in any order we want. So I prefer to look at this as 2 times 2 times 2. And then y times y times y. Or in other words, 2 to the third, y to the third. And then 8 y to the third would be the best answer. So let's look at what we ended up getting right here. And let's compare it. And if you were going to kind of tell someone what we do in this situation, I hope you would notice that, hey, all this means is that the 2 is going to get the exponent of the 3 and the y gets the exponent of the 3. It means 2 cubed and y cubed. 2 cubed and y cubed. That's it. So that brings us to our second rule of the day. Raising a product, so we have two things being multiplied already, raising a product to a power. So ab to the nth power just means a to the nth, b to the nth. Give the power to both. Pretty simple rule, again, based in logic. ab to the nth means take ab, multiply by ab, multiply by ab, and do that n times. Well, that's just going to result in us having a to the n's. We have 1, 2, 3, and however many n's we have, and we have b n's. NBs, I should say. Okay. Let's just do some examples. I think we'll find this to be okay. But again, the details matter. So the first one just tells me, oh, you've got two things being raised to a power. So that's going to be 2 to the fourth, x to the fourth. 2 to the fourth is a reasonable amount. Count it on your fingers. 2, 4, 8, 16. That's just 16x to the fourth. All right. This one, we're going to use both our rules from today. So the first one says the 4 goes to the 2 and it goes to the x squared. But when I apply the 4 to the x squared, we're using rule 1 from today. Power raised to a power, we multiply the powers together. So this ends up being x to the 8th power. Or, again, 16, x to the 8th. So each of them get the power. If they already have a power, then we use the first rule from today and we multiply them together. So this becomes 4 to the negative 2, g to the negative 10, which means they're both negatives. So they're going to end up in the denominator. 4 squared is 16, and g to the 10th is g to the 10th. They both get squared, and they both get moved to the bottom. Okay, let's do a couple more. All right, we got a lot going on in this problem. Let's do it step at a time. I have a base to a power to a power. That is the multiply them together rule. Then I have the factor, the product, rule, where I have multiple things being raised to a power. So this is going to be 3 to the fourth. It's going to be x to the fourth. And then it's going to be y squared to the fourth, which means there are 8 of those y's. Now we bring this together. 3 to the fourth, it's right on the border of big enough that maybe we can just leave it. It's 81. So I have 81. X to the negative 4 plus 4 is 0 power. So I have x to the 0 and only y to the 8th. Don't forget, x to the 0 is just 1. So I have 81 times 1, which we don't need, y to the 8th. Part E. Going to use the rule from today. They both get the 5. So that's 2 to the 5th. And then a to the 15th. Then I have 3 to the 3rd, a to the 3rd, b to the 6th. All right. So I have A's. I have 18 A's. I have 6 B's. And then I have 2's and 3's. Well, I don't want to leave the answer like this because that does not feel very simplified to me. So at the very least, I should figure out that 2 to the 5th, count on your fingers, is 32. 3 cubed is 3, 3 is 9, is 27. So this problem really just says 32 times 27, a to the 18th, b to the 6th. Now, I know this sort of violates my if the number gets too big rule, then just leave it. But the fact that we have 2 separate numbers makes it feel very unfinished just to leave it right here, right? So that's not ideal. Ideal would be to carry it further and then figure out what 32 times 27 is, which is 864, a to the 18th, b to the 6th. All right, and I think this is our last one for today. The 3 goes to all of this, so I've got 6 cubed, m cubed, n cubed, 5 squared, m to the negative 6th. All right, so again, I think these numbers are going to get a little ridiculous, but there's no way to combine the 6 cubed and the 5 squared together without just figuring out what they are. So let's do that last. I've got m cubed and n and m to the negative 6th. So that's m to the negative 3rd. So I took care of that and that. I only have one set of n's. So I took care of that. And then I've got, I guess it's calculator time, 6 to the 3rd, 6 times 6 times 6. That's 216. 5 squared is 25. So I've got this problem. So I should go ahead and multiply those together. So I'm going to multiply it by 25. So I get 5,400. What happens to these m's? They go to the bottom. And the n's are doing nothing. At the end of the day, like if you had left the problem as 6 to the 3rd times 5 squared, n cubed over m to the 3rd, I can live with it. I don't feel good about leaving this right here. And definitely don't try and force them together in a way that they don't go. There's no way to put those together in one thing other than figuring out what they both equal and then multiplying them. All right, so sticking with my theme, each rule is very simple on their own, one question at a time, not a problem. You start mixing rules, it can get complicated. So let's practice, let's gain confidence, and ask questions. All right, I hope this helped.